All right, everyone, welcome back to Calculus 3. So in this video, we're going to focus on 5.4 triple integrals. As you can imagine, we are going to take integral triple times, and then there should be a given condition when and how you're going to utilize triple integral. So we're going to use the three different variables of the function and find out each range, and we're going to take the interval. So very similar like a double integral, but I just want to talk about the background where this triple integral came from, and I will do a couple examples. So 5.4, it's a very short topic because you guys already know how to take the integral. Just we need to see how to deal with three different variable x, y, z. So let me show you the image. So since we are now going to deal with three variables, x, y, z. So far we've been dealing with one variable in calculus 2 was all about taking the integral with one respect variable. Calculus 3, we've been dealing with how to take the integral with the two variables of the functions, and one of the example was using two double integral. So now what if I have a three variable, and how would you be able to take the integral? So first of all, the first idea, you need to find out the range for each x, y, z, right? So that if you have, let's say, here is a cubic, and then let's say I have so many infinite number of the mini cubic, and then let's assume that you are evaluating the volume of this cubic. So the idea is, we could always think about the Riemann sum. So this cubic is one of the small, piece of the cubic inside of this blue. So that as you see that you have to consider x width, and you have to consider y length, you have to consider the height. So each x, y, z, we might have a different, interval, right? So that in that case, I want to find out the volume. How would you be able to find out the volume? We are going to take the triple integral, right? So that x is, somewhere between a and b, and then the y is going to be between, let's say, c and d, and z is between, let's say, r and s. So you are going to have a given, three different interval for each x, y, z variable. So if we have this condition, and we need to find out, the partition, the length, each, partition of x, y, z. So let's say, you're going to find out the, partition for x, you're going to find out the partition for y and z. And then if you multiply all those three, that's the volume. So mathematically, volume ijk, that means you multiply three different variables partition. So that's going to be here in the Riemann sum at the end, right? That's partition equal, volume of the, cubic. We assume that we have that idea because you're going to have many same size of the cubic, and you're adding all of them. It's going to cover the entire volume. That's what we are doing it. So that you have f, x, y, z. So now we have to consider, different, partitions. So ijk for each x and y. And then you're adding all the summation according to the Riemann sum. So P indicates basically I go to infinity, M go to infinity, N is going to infinity. We condense those information as a P. So that's the Riemann sum. Do you remember that? Like you are keep adding equal, length of the rectangular to find out the area. Same thing. You're keep adding same size of the cubic volume, okay, to cover entire this blue, cubic volume. So that's the same like a Riemann sum. So what I observed, we had a triple summation, right? This is the classic traditional way of finding the volume of three different variable. Now we are in modernized, math. We are changing that summation to triple, integral. And then same thing, you're going to have a given function. Take the integral for each x, y, z variable. So if you begin x, that should be the interval for x variable, y variable, z variable. So this is going to help us to find out the volume of the three variable of the function. So we are going to actually use this formula, the triple integral to find out sometimes the region of the three variable or volume of three variable. Does it make sense? So I just wanted to share, the background of why and how those triple integral, information came from. Same thing from the Riemann sum. You're keep adding, same size of the cubic. So there are infinite number of this cubic volume. Here, you're adding all of them so that you can find out entire volume of the cubic, right? So, we are not going to use a summation notation anymore. We are just using the integral. So, yep, this is going to be the, information we're going to use. So basically, the main key is define the interval for x, y, z. So this one might be a little bit tricky to find out the interval, but sometimes it is hidden when you read the question. So let's take a look at the example to solve the, take the triple integral question. Okay. So let me go to slowly, surely. So we got the concept. Ooh, this is exactly what I want to do. So they are asking you to use a triple integral to find out the volume of x, y, z, three variables of function. So I don't know whether they're looking for, it is a cubic or it is like, we don't know what type of shape look like, but the idea is we are looking for the volume of this function that include three variable x, y, z. So thankfully, they gave us the interval for each x, y, z, isn't it? So we can set it up. So this is going to be find out the volume dV, or sometimes you can write it you can also find out the area dA of the triple variable. So anyway, this is a dV. We are looking for the volume. So we can use a triple, and then the function is 8x to the second, y, z to the second, dV. This is what? Thank you. We have all the interval for x, y, z. This is the interval for each x, y, z. So you're going to write it, right? The function is here. And then you're going to write it. You can write it either at dx, dy, dz. Doesn't matter which one going to be first. You can do dz, dy, dx. Doesn't matter. You're going to get the same answer. So we're going to keep on going, just use dz, dy. I'm going to use this order. If you want, you can change that order, beginning dx, dy, dz, or dz, dy, dx, doesn't matter which one you want to prefer. Okay, so then now what happened? We have to plug in the interval. So dz first. So the dz is a 1 to 2. dy is going to be 0 to 1. dx is going to be -1 and 2. So simply you're going to take the integral inside first, middle, then outside. So if we are taking this triple integral, let's look at the first narrow information. So in this time, we are taking integral with respect to z, right? So that 8x to the second y, they are going to be considered as constant, just number. So you will be 8x to the second, y is still there, and then z to the third over 3, correct? That's what's happening. Oh, actually, I'm going to make this question a little bit easier because I don't want to have 8 over 3 ugly like a fraction. So let's change this to, sorry about that. Let's change this one to 3 because that's going to be help us to do easy calculation. So 3. So let's change it 3. So I just modified the question a little bit. So now 3 plus 1 is a 4 divided by 4. So because I want to divide it by 4 from 8. So now this is from 1 to 2. So if we do, so 2x to the second, y, z to the 4, 1 to 2. So you can simplify. That means f of 2 minus f of 1. So you're going to plug in 1 and 2 into the z variable because we are taking the integral with respect to z. So 2x to the second y, 2 to the 4 minus 2x to the second y, 1 to the 4. So what are you going to get? 2 to the first 16, right? Times 2, 32. X to the second y minus, it is going to be 2x to the second y. So I got 30 x to the second y. That's what we finished the inside. the little this inside. We finished that. So now I'm going to bring that number here. We still have negative 1 and 2, 0, 1, 30 x a second y. So we done this part. Now dy dx. So we're going to do this part. Now you're taking the integral with respect to y variable. So same thing, 30 x a second constant, y2 over 2 from 0 to 1. So cancel. 15 x a second, y second, 0, 1. So you have capital 1 minus 0. So 15, you're going to plug in 1 into y. 15 x a second. So this is going to be 0. So we have a 15 x a second. Almost done. So that was the first step. That was the second. Now we're going to go to third. So now final, negative 1 to 2, 15 x a second, dx. Perfect. So we are taking the integral with respect to x variable. So 15 x to the third over 3 from negative 1 and 2. Cancel. 5x to the third, negative 1 and 2. So 5, 2 to the third minus 5, negative 1 to the third. Okay, so let me finalize the calculation so you can finish that too. What you gonna get? That is gonna be 8 times 5, 40. Am I right? And this is a double negative 1 to the third. So it's gonna be negative 1. So 40, double negative positive. So your final answer, that's 45. So that's a volume when you're taking the triple integral with respect to x, y, z. So let me just change this one. Just I don't want to, okay, that's something. And then this one was a 3. Okay, so that's a triple. I told you it's a short concept. Just be careful. When you're taking the integral, something should be constant. So this one was like very, very warming up question because we are lucky because all the interval for x, y, z was a given. Sometimes it's not given, and then you need to create it based on the information. So I'm going to hold up here for example 1. Are you guys okay so far? Does it make sense to you? So if you guys been practicing, on taking integrals since calculus 2, this one should be fine. All right, I'm going to go down the next question slowly and surely. So take a look at the next one. So here, this is a very, very important concept. So if you remember, I explained very similar thing when you're taking the double integral for x and y two variable. So if you sometimes you have, only focusing on the x variable, depending on the y variable, we have a different situation. So here we have a very similar thing with 3 different variables. So here I'm going to write it something, or actually I'm going to highlight it with the important color. So next we consider integration over bounded solid region of a more general shape. There are actually 2 types, my bad. So let me just change it to 2 type of a bounded solid region. So what that means is there are type 1 case. A solid region E is said to be type 1 if it lies between the graph of 2 continuous functions of x and y. If your function is between 2 continuous function x and y, z, that means you do not really care about the z, okay? So then you have to find out the region E, x, y, z. The G is going to be between above, below 2 different functions. So sounds a little bit abstract. I got that. So one case is simply you are going to find out the triple integral, to find out the volume. So let's say this is the image. So I have, let's say, very ugly shape here, something going on. And then this function is going to be, your function is only has a 3 different variable x, y, z, but then you have only z interval given. Okay, in that case, the interval is also part of the function. So what I'm saying is, sometimes like the interval is not between two simple numbers, like a 1 and 2 or 2 and 4. Sometimes this interval given by function. I'm just creating, right? So to find out the interval of z or x and y, if you have a interval based on the function, you have to evaluate it, what that is. Okay, it could be like 2x minus y, 3x minus 3. So sometimes it's not between simple number like 1 and 2, we just observe. Sometimes the interval of z is given by the function with respect to x and y variable. So that's what I'm saying. So z interval, because this is going to be 3 variable, each x or y or z variable can be written by the function. So that z interval is going to be between x, y, two different variables of function. Okay. So that's a case 1. When z interval given with the function that include x and y, then you're going to begin taking integral with respect to z first, because that's a given. And then you're going to consider whatever the rest of x and y interval. Sometimes it is not given, then you have to find it. Find it the rest of x and y variable. If this function is very complicated, if you remember, we're going to change to the polar coordinate interval. So that's what I'm going to show you very soon. But according to the textbook, this is a type 1. I know it looks a little bit complicated, but the only one thing is you're going to have the interval for z, right? And then you want to find out the interval for x and y, but it's not given. But then, you can find out the interval for z's interval. It's given by function. So that by using this information, you might be able to find out the interval for x and y. Sometimes it happens, sometimes it's not. Then we have to consider to change it to the polar coordinate interval. So I will show you that example very, very soon. But keep in mind, this is a type 1 region. When you have a given interval for z only, so that means this interval, this region is a projected of E onto X and Y, Z. This is what the corresponding sentence. So this is what they're talking about. Okay, so that means you have only interval for Z. So likewise, I know it looks a little bit complicated abstract concept, but I will show you examples soon, so you're gonna be fine. But another one, type 2, okay? Type 2, it's more complicated, I got it. So you still have the interval for Z, but then the interval is given by the function that include only Y and Z. So X is missing, okay? That's a type 2. So we have those type 1 and type 2. So if you have that case, oh, actually I have a little bit of typo. So my bad, this one should be X because we have 3 variables. So that should make sense now. So type 2 is when you have the interval for only X, and then obviously the other, function gonna be include Y and Z. And then what happened? If you have interval for X, yes, you can take the interval X first. And then the same thing, you might be able to find out the interval for Y and Z depending on question. So I'm going to show you type 1 and 2. So type 1, I'm going to write it. Interval Z is given by f(x,y) function. Type 2, the interval of X is given by Y, Z, 2 variable function. So this is a type 1 and 2. Honestly, when you solve the question, it's not really matter which one you're going to use, type 1 and type 2, because your goal is to find out all the interval for X, Y, Z anyway. But just textbook is just showing you, theorem all the time. So just be aware there are 2 type 1 and type 2. and then check it out which interval is given. And then you can begin how to set up the interval, which one you have to do first. So z interval given that go to z first, x interval given that x, take the integral with x respect variable, you're going to take the integral first. So anyway, I just try to explain easier way, but let's really do the question. So maybe we have a better understanding what is going on. So if you guys okay, I'm going to go down slowly. Okay. So here we go. This is the question. So I just wrote down, this is a type 1 definition. So the z interval given. So you have to take the integral with z first. So anyway, let's read the question. Evaluate the triple integral. So the function is very simple. Ooh, it is a z. And they want to find out the volume of the function z, where E is a solid division bounded. So they have a specific interval, x equal to 0, y equal to 0, z equal to 0, and this is the function. Okay, we have a lot of information going on. First, let me just look at the image. What is going on actually? So x here, y here, z here. So I want to find out the vertex point of each x and y. So we have x plus y plus z equal to 0. So if you can solve for each x, y, z, actually my bad, this is 1. So when you're adding 3 number equal to 1, so we have 3 cases, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the case we can think about it. So we have 0, 0, 1 here. We have 1, 0, 0. We have a 0, 1, 0. So this is like that shape. You can think about 3-dimensional image. So that's the image of x plus y plus z equal to 1. And actually I can solve for z because that's going to be the graph of this shape. Actually, this shape is tetrahedron. That's the shape name. And then if you solve for z, I'm going to move everything the other side, 1 minus x minus y. That's the equation for z. So that's what I know so far. We have to take the double integral, right? We have to take the double integral of that function. So let's keep checking what else we can do. So you can think about the interval for each one. So let me look at the question. I think we have to have a specific information of f, x, y, z. So I'm going to add some information here because we do not have enough equations. So what I'm going to do, I'm going to modify this question a little bit. I'm so sorry. So we are going to evaluate because this is a little bit too simple. So I'm going to make it a little bit complicated. So let's say we are going to evaluate the triple integral where I'm going to get rid of this everything for you because I want to solve more. So I'm just looking at, this is one of the example in textbook. Let's say f, x, z, it is a given 5x minus 3y. So let's say we have a given x, y, z. It is 5x minus 3 over the solid region bounded by the plane x equal to 0, y equal to 0, whatever. So this is given. Okay, so we good. So now we can set it up. Okay. Now we can continue. So now I want to find out the interval for everything. So here, what do you guys think? We have x, y, z, that's the function, such that you need to find out the interval for x, you have to find out the interval for y, and you're going to find out the interval for z. So we have to find out that too. So let me just get rid of here. Z. So this is something we need to define first. So what is going on? First of all, the z is a given, right? Between, depending on as x and y changing, z is also going to be changing. So therefore, I can set up. So let me just get rid of it. So first, z, I can say it's going to be greater than 0 or equal to, and then they are going to stop 1 minus x minus y. That's one interval for z we can find out. What else we can do? Also, we need to find out the interval for y and z. So one thing you could do, so just look at the x and y. So x and y, x here, y here. So let's say they have 1 and 1, right? So 1, 0, 0 here and 0, 1. Let's say we have this. And then you can find out the equation for y, okay? So y is going to be 1 minus x. Because you can find out here or here, doesn't matter. So you are trying to find out the interval for y, right? And then we already know that z, you don't need to consider z, just solve for y by ignoring z, so y will be 1 minus x. You can do that way, but you can just look at that. If this is 1 and 1, this is a linear equation for 1, 0 and 0, 1. So that's the y interval. And then if these are true, the x interval is going to be 0 to 1. So this is how we set up the interval for x, y, z. So this is a little bit challenging all the time. Many people confuse. Think about it. We are trying to first find out the interval for x, y, z. So my best suggestion is use the given information. We already know the z interval from 0 to 1 minus x minus y. Okay. These are going to be changing depends on x and y variable, correct? So you cannot say it's going to be from 0 to 1. No, this is just vertex, right? Z variable is changing depending on x and y variable. And then once you have a z, go to y. Y is going to be also changing depend on the x variable. So that it's going to be between 0 and 1 minus x. And then x is the last one. You don't need to changing depending on x and y, just depending on 0 and 1. So we are from the large variability, middle variability, and smaller variability. So that's, you can set it up. Okay. Now we can take the triple. So I have a function 5x minus 3y, correct? If you want, you can begin dx, but I'm going to have dz interval first. So I'm going to set up this order. So you have a 0, 1 minus x minus y, 0, 1 minus x, 0, 1. That's it. That's all you need to calculate the rest of work. So the bottom work, 5x minus 3y is a constant because we are taking the integral with respect to z. So that's going to be 5x minus 3y, just increasing z from 0, 1 minus x minus y. That means you're going to plugging in 1 minus x minus and 0. So that's what we got. And then we are going to do the next one. 0, 1 minus x, we have a 0, 1. We have a 5x minus 3y, 1 minus x minus y, dy, and then later dx. Okay, so first I'm gonna just clean up this part. So you're gonna do all the distributive property. 5x minus 5x second, 5xy minus the 3y, 3xy, 3y second. Now you are going to take the integral with respect to dy. So let's do the work. So 5xy increasing, 5x second y, they are constant. 5xy to the second over 2, 3y second over 2, 3xy second over 2, 3y to the third over 3. And then 0, 1 minus x. It's going to be getting complicated, but I'm just showing you one time. And then the rest of work will be very, very same. So anyway, let's simplify. So I have a 5xy minus 5x second y minus 5 over 2 xy. I don't need to make a parenthesis. Xy second. 3 over 2 y second. 3 over 2 xy second. Y to the third. 0, 1 minus x. Again, now you're going to plugging in 1 minus x into y. It's going to be a lot of work. 5 x second. 1 minus x second. 5 over 2 x, 1 minus x to the second. 3 over 2, 1 minus x second. 3 over 2x, 1 minus x second. And actually, I need a space. And then last one, we have, where? Plus 1 minus x to the third. Woohoo! Okay, we got it. And then 0 is going to be subtract 0. So at the end, 0, 1, you're going to take the dx. But let me condense it. So what I'm going to do first, I observe that, right? In each term, there's a 1 minus x. So that's going to be their common factor. Am I correct? So I can take out 1 minus x to the front. So 1 minus x, 5x, and then minus 5x, 1 minus x to the 1 remaining, 5 over 2x, 1 minus x remaining, 3 over 2, 1 minus x remaining.
Excuse me.
Yes.
And one step earlier, one step above, the second power of 2 should be no power, only power of 1.
Which one are you talking about? This part?
Get down one line.
Here?
Yeah, the second part.
This one?
Yeah,
yeah.
1 minus 1.
Yes, we don't have a second power. You're right. So let me get rid of this one. So we don't have 1 minus x. You're right. So that this is what happened, correct? And then we have a second power here. Better? Yeah, I think so. So I just made a little mistake. It was just y, so 1 minus x. And then x, just 1 minus x, 1 minus to the second. Woohoo, all right. Okay, we are going to try to simplify the work here. What I'm gonna do, let's expand everything here. So 5x minus 5x second, 5 over 2x plus 5 over 2x second, 3 over 2 plus 3 over 2x, sorry, 3 over 2x minus 3 over 2x second, and then 1 minus, you can simplify that word, 1 minus 2x plus x second. Okay, so now I'm trying to combine in like term. Minus 2x second, 5 over 2x second, minus 3 over 2x second. These are all the x second family. So minus 5 plus 5 over 2 minus 3 over 2 plus 1. These are all x second family. We have a 1 minus x in the front. All right, you can simplify later. And then x family, 5x, oopsie, x family, minus 5 over 2, 3 over 2, 3 over 2, minus 2x. So if I do, that is going to be 5 minus 5 over 2 plus 3 over 2, 3 over 2, minus 2x family. And then last one, number family. So that's going to be minus, you're going to adding. So you can add minus 3 over 2 plus 1. So if I similar, and then we are going to, at the end, dx. Whew, all right, almost done. Can we simplify this one? -5. So this is going to be -4 plus 2 over 2. It's 1. Okay, we have here -3x a second. Gotcha. Keep going. This part, what is that? 5 minus 2, it's a 3. And they're all common denominator. Plus 6 minus 1 over 2. So this is going to be 7 over 2. 7 over 2x. And then this is minus 1 over 2. Got it. And then we have a 1 minus x in the front. Okay, now we can do dx. I'm going to try to simplify more and more so you can do the distributive property. So 0, 1 minus 3x a second. 7 over 2x minus 1 over 2. Double negative 3x a second. 7 over 2x plus 1 over 2. Again, you can simplify all the work. Okay, x a second cancel. Wait, everything is a cancel, isn't it? Is it really? Is there any mistake do I have? No, right? I don't have any mistake. So let me just double check. 1 second. So I took the integral. 1 second. My problem was I didn't take the integral. Sorry, let me go back to the work. 1 second. So when we have too much work, you see that we are making a mistake. So let me just go back here. I didn't take the integral yet. I just simplified. So let me just go back where I stop it. So actually we took the integral. So I'm plugging in We are working on dy, 1 over 1 minus x. And then we do have 5xy, Okay, 1 minus 0. Okay, I think I'm okay so far because I already took the integral right there. Here, these are although we finished the integral, right? So we're plugging in 1 minus x there. So I think I was on the right track. So 0, 1. 1 minus x. That one was what? -3x a second. 7 over 2x minus 1 over 2. Okay, now I'm going to do one that was -3x a second. Sorry, I'm just doing the same work one more time. 3x is third. That was a third. And then that's why it was not canceled. Plus, actually minus 7 over 2x a second plus 1 over 2x. All right, now I see where I made a mistake before. So that's what it is. Are you following? So if you want, you can simplify the common like term. So one more time. X a second family. X a second family here. Cubic. And then X family and number family. So if you're adding this two, what is it? It's a negative 613 over 2x a second. I have a 3x a third plus 8 over 2x minus 1 over 2. And then 0, 1 dx. Am I correct? You can always check my work. Okay, now take the integral. X to the third over 3. 3x to the 4 over 4. 4, because 8 divided by 2, 2. 1 over 2x. 0 to 1. Gotcha. So that's -13 over 6x to the third. 3 over 4x to the 4. 2x to the second, 1 over 2x. So now you're going to subtract 1 to 0. So basically, you're going to plugging in all the 1. So that negative 13 over 6 plus 3 over 4, 2 minus 1 over 2, and minus 0 is 0. So you're going to calculate that. So we can have all the common denominator 12. So negative 26 over 12, 9 over 12, 12, 24 over 12, that's 2, and 6 over 12. So what you're going to get? Let's calculate that number. So 3, so we have negative 26 plus 9, that's negative 17 plus 24, that's 7, minus 6, we have 1 over 12, that's the answer. Woo, we got it. So I told you, just it's a long calculation, but you guys already know how to take the integral. So that's a little bit long word. Welcome to the triple integral. That's what it is. Just, step by inside, middle, and outside. Just be careful. Sometimes, you can make a mistake what I did, but the answer should be simple. So we did the same work. You can find out the answer, same thing in our textbook, 1 over 12. That's the answer. All right, so I'm sorry if I make you too confused, but the calculation is not that confused. Just it's a long version of the extension. So it should be okay. I'm pretty sure you're gonna be fine, but I'm gonna take a breath for a second. Are you okay? Are you okay? Okay. All right, so if you got that one, I love to see your thumbs up. Okay. So that's a triple integral that I did. So we just, the most important thing is find the integral, find the interval for each x and y. Setting up the triple integral, it's not that, hard. Just the calculation part, it's a work. So anyway, that's how we finished the triple integral right there. Okay, so if you got that one, can you show me your thumbs up? Are you happy? Are you okay? Okay, I see a couple thumbs up. So now I'm gonna just practice 2 more, that's it. 5.4, honestly, we don't need to spend too much time because we know how to take the integral. This is just triple, that's it, right? I'm gonna do just 1 more. Sometimes we have to be careful to define the interval for each x and y, z. That's a challenging part. So let's practice here. So this is something we're gonna do. I think definitely we need a space. So let's do example 3. So I do have triple integral. They say this is the function, find out the volume, and then I'm going to give you the hint to find out the interval for x, y, z. So we have a radical y second plus z second, right? So the x is open. So if you graph it, the x-axis open. So actually, this is a second power, and then the 2-dimensional image is going to be circle because it looks like a circle. And then the solid region bounded by the parabola, x is going to be y second plus z second, and x is going to be 9. So there is a hint. This is a type 2. They already gave you the interval for x. This is a type 2. So from here, I can find out the, the range for x, y, z. X, y, z, such that x interval is going to be between where to where? Y second, z second, and they stop at 9. And then I don't know other interval for x, y, and z yet. That's okay. This is a type 2. So we have to define. So first we know if you have only this information, the triple, it is going to be, we have function y second, z second radical, right? And then you're going to take the dx first, correct? This is a type 2. Because we have an interval for only x. So this is going to be y second, z second, and 9. And I don't know anything. dy, dz. I don't know yet. right? So we have to think about it. First of all, it's hard to solve for, what the y, what the z. So due to this complicated function, why don't we convert this to the polar coordinate system, r comma theta, right? And then this is the xyz. And then x is going to be open. This is going to be the sum shape, right? That's the sum shape of this function. And then the radius is going to be between, y second plus z second to the 9. So anyway, that's something going on, right? This is the something going on. And then we have a limit to find out, like if you want, maybe we can find out by using some other model, but it's a little complicated by hand. So I determine we're going to convert it to the polar coordinate system. Okay, so let's do that work. So therefore, we're going to convert it. So the polar coordinate, we're going to use simply r and theta. Okay, and then because x is a 9, right? You can find out the radius of the circle, right? This is the radius of the circle. Anyway, it's going to be 3, but r is going to be between 0 and 3. So something we can discover that information for the for r. And then if you remember the circle, always 0 to 2 pi. So that's how I converted. This is a new interval in terms of the polar coordinate, right? So we're going to convert. We're going to convert this ugly, right? This ugly triple integral into the polar system. So let's think about step by step. First of all, I can calculate this part, right? Before we're going to go to polar. So let me finish that work first because I want to make it simple as much as we can. So if you're plugging in, this is the constant you can consider. So if you take the integral, this is y, I'm going to use the same color. So I'm going to plug in here. So it's going to be radical y second, z second constant, and we are taking the integral with respect to x. I'm going to just add x there. And then from y to the second plus z to the second to 9. Right, that's it. And then that means radical y second z second times 9 minus radical y second z second, right, times y second plus z second. Are you okay? That's what they mean. Capital letter of 9, capital letter of this. And then I can simplify this common factor. This 9 minus, because of negative, y second minus z second. So this is, we finished the first integral inside. So we're going to start from there. That's why we have only y and z. So we have now double integral, no more triple because we finished one of them. So y second, z second, 9 minus y second, z second. And then this is going to be right now dy dz. I don't know the question mark, the interval. So we are changing into the polar coordinate system. So we have here so far, and we have this. Okay, we good. Are you okay? Because I want to finish as much as I can do in the regular rectangular system. Then if you cannot do anymore, we're going to switch to the polar coordinate system. All right, so now the fact is, okay, if you remember, according to the polar coordinate system, r second is going to be whatever two variable seconds addition. Do you remember? Like r equal to x second plus y second, according to the polar coordinate system. So here we have only two variable y and z. So we know there thus r second is going to be y second plus z second according to the polar coordinate system definition. So we're going to utilize this fact. Now we're going to modify everything into polar coordinate system. So we can do integral, and then now y second plus z second, that's going to be r second. And then 9 minus, I can common factor minus y second plus z second. And then according to the polar, there's r at the end, and you have to dr and d theta now. So this is the formula, if you remember. Always you need to multiply r at the end of the function. So again, this is going to be r second, again, correct? So we have, this one is a cancel, r, 9 minus r second, we have r, dr, d theta. So since the dr here, what is r radius? Right there, 0 to 3. Theta, 0 to 2 pi. So that's, you're going to set it up according to the polar coordinate double integral. The rest of work, simple calculation. Let's do inside. So if you simplify, 9 r second minus, I just expand everything, r to the 4 dr. And then after that, you're going to do, take the integral d theta. So if we finish, 9r to the 3rd over 3, r to the 5th over 5, 0 to 3. So that means cancel 3 to the 3rd minus 3 to the 5th over 5 minus 0. So it is going to be, 81, right? 81 minus, what is the 81 times 3? 243 divided by 5. We cannot simplify, so I'm going to keep it. So that's it. That's what we got. And then now we have to take the outside 2 pi. 81 minus 243 over 5 d theta. That's all we need to do. So we are going to increase because they're constant. So 81 minus 243 over 5 theta from 0 to 2 pi. So if you're plugging in times 2 pi and then minus whatever, it's going to be 0. So the answer is going to be that answer. You can just simplify, go to decimal. You can convert it to the decimal. So let me find out that answer for you. The answer should be 81 minus 243 divided by 5. And then you're going to multiply 2 pi. 2 pi. So the answer should be about 203.58. That's the answer. So in this question, I show you we had a limitation of finding the interval for y and z in terms of the rectangular system. Therefore, once you finish the first integral in terms of the x, we convert it to the polar coordinate system because that's easier to find out the radius, because this is a literally circle function, and then you can find out the angle from 0 to 2 theta. So therefore, polar coordinate system is much easier to find out the interval for y and z, but we convert it to the r and theta. So therefore, the second part was the double integral with the r and theta. So this is something you need to think about it. So I show you the basic information, how to take the triple integral, and then sometimes the interval is not given, you need to find out. And then when you have a limitation of taking the integral with respect to the rectangular system, we had a limitation to find out other intervals, then you're going to convert it to the polar. So that's pretty much the main question you will see in the quiz. But I'm going to do one last example. Okay. So I think this is going to be okay. Can you show me your thumbs up? Does it make sense to you so far? Got you. So definitely, practice and solving more example give you a better idea. So, take a look at the, textbook. You can find out more example. Okay, now I'm going to do one last concept, how to find out the volume one more time. So let's do this example. So sometimes, this is a second concept in 5.4. We know that, if you are thinking about, let's say, the volume concept, I'm trying to fill out this space, okay? We consider, if you can fill out, we can consider it is 100% filled, correct, out of whatever the shape. So mathematically 100% is 1, correct? So because of that concept, you are going to consider function as 1, and then you can find out actual volume by taking the integral, triple integral. I know sounds a little bit abstract, but this is already given the function 1. You're gonna start from 1. So the volume of a solid region, you can use many different ways to find out the volume. So this is one of the way. You're gonna start from 1 and then take the triple integral, and then you're gonna find out the true volume, because your interval will be given. So sometimes you might be filling only this part out of total, right? That means your interval will be different. So the rate of change of the lengths, width and height are changing, depends on other variable. So that's why finding the interval important, but the given function, we're gonna begin with 1, okay? Then you're gonna find out the true volume based on the interval that you wanna have. So this is just the idea, and let's take a look at the question so that you will see what we're actually doing. So find the volume of the tetrahedron. And as you see that, this is the information. Actually, I have a little bit of typo. It should be equal. This is the information for the interval for x, y, z. But do you see the given what x, y, z function? It's not given. So that means you can use this one. You can use 1. You can begin 1 to find out the true volume based on the interval that you're going to find out. Okay. So let's find out the interval for x, y, z. So in this case, your function is going to be 1. Okay. So let's find out the interval for x, y, z. So such that you can solve for z. So always my suggestion, find out the interval for z. So because this is the equation for z. So z is actually 12 minus 2x minus 2y. So that it should be positive interval. So that is going to be, z is going to be 0 between 12 minus 2x minus 2y. So this is the interval for z. We good. So what that means is the z, right? It's going to be changing, depends on the two variable x and y. We good? So likewise, we need to find out the interval for y. So what I did, you can solve for y. Now we solve for z. So you don't need to you can get rid of it. So now 2x plus 2y equal to z, just solve for y. So 2y will be 12 minus 2x. Y will be 6 minus x. So it's going to be between 0, 6 minus x. That means y variable is changing, depends on the x variable. Are we okay? So we had a 2 variable, now 1 variable. So we're going to find out the x interval. X is going to be between the constant. So now this is we have a last equation. Now you're going to get rid of x and y both. So now 2x equal to 12, x equal to 6, x is going to be between only 0 and 6. That's it. That's how you're going to find out the interval. So I just want to show you the technique how to find out the interval for x, y, z. Begin with z, then go to y, keep reducing down the variable, because z variable is only changing by x and y. Y variable is going to be changing dependent on x. X is changing dependent on the constant. So that's, you set it up. Good job. We got it. So now we're going to set up. In this time, the function is not given. So we're going to triple 1 and db. But in this time, we're going to have all the interval. So dz first, dy, dx, the z, 0, 12 minus 2x minus 2y, y, 0, 6 minus x, 6 and 6. That's all you need to do. That's it. So when you do not have a given function, assume that total, field is going to be 1. You're looking for whatever the function, whatever the volume, depending on the interval. So we are looking for, depending on the interval is given. Okay. All right. We are so good. I think we are doing fine. Okay. The rest of work, it's just calculation, isn't it? So you can do the inside first. So now it's taking the integral with respect to z, so that obviously we don't need to change it to the polar coordinate system. Everything is a given, the interval for given for x, y, z. So this one, z, 0, 12 minus 2x minus 2y. That means just 12 minus 2x minus 2y. So now we finished the first interval. 0, 6 minus x, 12 minus 2x minus 2y, and we are taking the integral dy. So that is going to be 12y, 2xy, 2y to the second over 2, 0, 6 minus x. Are you okay? So this is the first integral, second integral, the inside middle. So then if you're plugging in 12, 6 minus x, 2 times x times 6 minus x, and then cancel, 6 minus x to the second. For the next and then 0 is a 0. I want to expand it at 72 minus 12x, 12x plus 2x a second. And if you actually calculate that part, 36 minus 12x plus x a second. So let's simplify. 72, they're going to be negative 24x, 2x a second, and then distributive property with the negative number. And then simplify x a second, 2 minus 1. And then minus 24 plus 12 minus 12x. And then 72 minus 36, 36. So that's what we done. Now we're going to go to the last one. We finished the middle, go to last. So that is going to be 0, 6, x a second, 12x, 36 dx. Dun, 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 dun. So x third, 12 second, 36. And, 36, that's it. And then from 0 to 6. So 6 to the third minus, this is a 6. 6 to the second, 36 and 6, and minus a 0. So all you need to do, calculate this part. So you can calculate it. I don't know. Let's calculate it. I can go to decimal if you want. So plugging in 6 times 6 times 6. 6 times 6 times 6, it's a 216 divided by 3 minus, again, 6 to the third, 216, and then plus, what is it? 36 times 6, just 36 times. And 6. So I'm just using decimal to calculate it. Ooh, I got it, 72. So that's the actually volume. They're only filling out 70, 3 out of 100. That's what that means. Okay. All right, we good. We got this concept based on that interval. Okay, we awesome. Are you happy? I told you 5.4, just taking double, 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 triple integral. That's all. Okay. Can you guys show me your thumbs up if you guys are happy? If you got that one? So I think you guys have a better confidence what we're doing. Yes, yes, yes. All right, last one. I'm not gonna finish. I'm gonna help you how to set up that equation first. The rest of work, you can try that. But let's do one more. Okay, so find the volume of this ugly shape. I don't know how much they're gonna fill out. Again, do they give us what the f of x, y, z function? No, they didn't give us. They gave us this, whatever the function is bounded by this information, these are gonna be used for the inable, correct? So anyway, we're gonna find out the volume by using the triple because XYZ beginning 1. And then depending on the inable, you will find out the true volume out of the total. All right, so let's look at that. First of all, you know, we need to find out the inable for XYZ, correct? What I have, we have a 4x second plus z second 4. So I'm gonna begin with here because I see z here. Maybe it helps us to find out the inable for z. So we're gonna solve for z, just solve for z to find out the inable for z. So the other equation, there's no z, so actually here too. So let's see what we're gonna get from here. Z second, I'm gonna solve for z, 4 minus 4x second. That means I can find out the common factor for 1 minus x second. Are we okay? To solve for z, I'm gonna just move it here, move it. All right, here. Now z equal to plus minus 4, 1 minus x second. So if that means what? This means plus, you can separate it. Radical 4, radical 1 minus x second. 4 is a 2. So plus 2, radical 1 minus x second, minus 2, 1 minus x second. So actually, this is the inable for z, right? This is going to be related to y inable, but hold up there. Let me just write it. So first of all, the whatever the e, we have x, y, z. The z inable between, okay, let me bring here, minus 2, 1 minus x second, plus 2, 1 minus x second. So z variable is changing depending on x variable only here, okay? Nothing is special. Because sometimes it can be affected by 2 variable, 1 variable. It's depending on the function, okay? So you don't need to always has a fixed mindset. Z is going to be changing based on both x and y. It could be happening, it could not be happening. But in this case, we find out the z inable between that information. And then let me find out y. Y is actually given, so perfect. Y equal to 0 and y equal to z plus 2. That means what? Between 0, z plus 2, isn't it? So simple, that's it. And then we need to find out the x inable. So x inable, where is x? We do have here, actually here, right there. So think about it. Inside of the radical cannot be negative number. So only option we do have, 1 minus x second, it is going to be, if it is a 0, then we fail to find out the inable for z and y, everything. So we're gonna solve for 1 minus x second 0. So that means x second equal to 1, right? If you convert it, change the order. So x is going to be plus minus 1. You are not going to have anything that is a larger than, 1 or less than negative 1. It should be between minus 1 and 1 because think about it. If x is a 2, the inside is going to be negative number. 1 minus 4 is a negative, fail. If you have a 0, 0, it's going to be still 1. So x should be only between negative 1 and 1. That's only possible. So that's how you're going to solve for x, y, z inable. So this is a little bit tricky, but I didn't create anything. I just use only the given information, guys, right? So find out the z variable, z inable, y inable, thank you, it's a given. And then think about where is x. Here, we have a limitation. X cannot be negative number. X should be between negative 1 and 1. So that's all your inable for x, y, z. So the rest of work, it's going to be triple. We do not have a function. Just write it, begin with 1. And then dz, you're going to go dz if you want, go first. Then dy, then dx. So that 2, 1 minus x second, actually minus positive 2, 1 minus x second, 0, z plus 2, right? And then here, you're going to have 0, negative 1 and 1. So I'm not going to calculate this one. Try that. You know what to do. It's going to be a little bit of a long process. Okay, but I'm pretty sure you could try because I show you. You're going to do inside and the next one and the next one. The answer is actually very simple, but I want you to just try that. A little bit complicated, but you're going to start from 1, take the integral. So it's going to be just a z and then negative 2, 1 minus x second plus 2. And then you're going to subtract, then go to y, then go to x. So you should get 4 pi. That's going to be the answer. But try to show me your work. Okay. But, you know, as long as you can set up the right triple expression, including the correct interval, the calculation part should be fine, right? Because the problem is I don't know how to set up the interval. That's a problem. Okay, so read the question. Don't try to create something new equation. No, just use the given information. That's all. Okay, so for 5.4, we've been practicing just fundamental skill on how to take triple integral, and then we just saw that you have to manage it 3 different variable because it is a triple. And then 5.5, next video, we are going to see more applicational problem where the triple integral actually used to find out like other shape. So this is one example. It could be find out the cylinder shape more concretely, or you can find out other shapes volume. So triple gonna give you better accurate answer. So if you remember calculus 2, you also were able to find out the volume by taking the integral, but whatever the answer you got, that was approximate answer. Do you remember that? Integral help us to find out approximate answer, right? So by taking integral, we can find out better precise answer. So let's take a look at 5.45 in the next video. And 5.4, we just practiced what the triple integral means and how to use it. Okay, so I will stop recording at this moment. Thank you for watching this video, everyone. I will see you guys in the next video. Bye-bye.